Hello, students. We start our lesson by interchangeability, standardization, and technical measurements. Team 2, size tolerance, joints, fits. Plan of our lecture: 2.1, the concept of size tolerance. 2.2, graphic representation of tolerances and deviations. 2.3, general information about fits. And now we start 2.1, item 2.1, the concept of size tolerance. The actual dimensions of the parts must be within acceptable limits. The limits in each case are determined by the size limits or deviations. These limits define the concept of size tolerance. Tolerance, big T, designation, big TD, hole tolerance, TD small, shaft tolerance. We always use small d if we use for the shaft. Tolerance is equal to the difference between the largest and smallest limit sizes. So you can see the formulas to determine tolerance field for the hole and for the shaft. The difference between maximum diameter and minimum diameter of the hole and maximum diameter and minimum diameter of the shaft. Or the absolute value of the algebraic difference of upper and lower deviations. The tolerance field of the hole is equal upper limit deviation of the hole minus lower limit deviation of the hole, and tolerance field of the shaft is equal upper limit deviation of the shaft minus lower limit deviation of the shaft. Graphic representation of tolerances and deviations. The graphic way of displaying tolerances and deviations is highly visual. This method allows you to quickly determine the nature of the connection of parts and facilities the various calculations related to the accuracy of parts and joints. In all usable parts to be assembled, the dimensions of the matting surface are in the range from D maximum to D minimum for the hole and from small d maximum to small d minimum for the shaft. In the graphical representation of tolerances, instead of details on the diagrams, give conditional images of holes and shaft without scaling. The scale in the construction of such schemes cannot be sustained because the tolerances for the processing of parts are hundreds and thousands of times smaller than the nominal size. In this figure, what you can see the tolerance fields of the hole, tolerance field of the hole, and tolerance field of the shaft. In this scheme, tolerance field of the hole is determined like big TD, and tolerance field of the shaft, it's TD small. We have maximum size of the shaft and minimum size of the shaft in and interval tolerance grade. fundamental deviations, lower deviations, and upper deviations. It's for the shaft and for the hole. Lower deviation, upper deviation, minimum size of the hole, and maximum size of the hole. In the figure in the corner of the slide, you can see nominal diameter of our connection. It's 12 millimeters. You can see minimum diameter, lower diameter, minimum size of the shaft, and maximum size of the shaft. Between this row, between these lines, there are tolerance field of the shaft. Upper limit deviation of the shaft, small es, lower limit deviation of the shaft, small e. Maximum hole size, d maximum, and minimum hole size, d minimum. Between these two lines, there are tolerance field of the hole. And we have upper limit deviation of the hole and lower limit deviation of the hole. And you can see maximum clearance and minimum clearance in this connection of the hole and shaft. Draw a horizontal line which is called the zero line. Zero line, a line whose position corresponds to the nominal size, like in this figure, d nominal is equal 12 millimeters. Deviations from it are postponed. Positive up, negative down. The diagrams indicate the nominal and limit dimensions, limit deviations, tolerance fields, and other parameters. It's tolerance field of the hole and tolerance field of the shaft. Upper limit deviation and lower limit deviations of the hole, big ES and big EE. Upper limit deviation and lower limit deviation of the shaft, small ES and small EE. The limit dimensions of the hole and limit dimensions of the shaft. Minimum diameter and maximum diameter of the shaft, and minimum and maximum diameters of the hole. And maximum and minimum clearance between hole and shaft. Tolerance field. In this scheme, tolerance field of the hole and tolerance field of the shaft. Tolerance field, a field bounded by the upper and lower deviations. The tolerance field is determined by the tolerance value and its position relative to the nominal size. This provisions is determined by the main deviation, fundamental deviation. The main deviation is the deviation that is smaller in absolute value. For the hole, it's big E because is equal 0, and he has the smaller absolute value. The main deviation of the shaft, it's small ES, upper limit deviation of the shaft, because it have the smaller absolute value. Limit deviations are plotted from zero line and their numerical values determine the magnitude and position of the tolerance field relative to the same line. This allows you to apply a simpler way of graphically representing the tolerance fields only due to deviations. Nominal and limiting dimensions are not indicated on such simplified schemes. The position of the zero line always corresponds to the end of the vector of nominal size. It's vector of nominal size, which is conditionally directed from the bottom up. Thanks to these simplified schemes can be drawn to scale, they are more visual, simple, and compact. You can see tolerance field of the hole because we use big TD. Tolerance field of the shaft, and we have upper limit deviation of the shaft is equal plus 0.431, lower limit deviation of the shaft is equal plus 0.350, and for the whole upper limit deviation of the whole BKS is equal plus 0.081, and BKE is equal 0. It's lower limit deviation of the whole. And next item of our lecture, 2.3, general information about fits. The mechanism of all machines are devices consist of parts and assemblies. In some cases, it is necessary to obtain a movable connection with a clearance. In others, a fixed connection with interference. The clearance, big S, clearance S, is the difference between the size of the hole and the shaft if the size of the hole is larger than the size of the shaft. And S is equal diameter of the hole minus diameter of the shaft. Interference N, big N, is the difference between the size of the shaft and the hole before assembly. If the size of the shaft is larger than the size of the hole, and interference is equal diameter of the shaft minus diameter of the hole. Clearances and interferences are provided not only by accuracy on the size, but also by the ratio of the sizes of the connected surface. Fit. 3 groups of fits. Fit is the nature of the connection of parts due to the size of the clearance or interference. Depending on the location of the tolerance fields of the hole and the shaft, fit are subdivided into 3 groups. First group, clearance fits. Second group, interference fits. And third group, transition fits. Clearance fits are fits that provide clearance in the joint. Interference fit are fits that provide interference in the joint. And transition fits make it possible to obtain both clearance and interference in the connection. First group, clearance fits. Clearance fits are characterized by limit clearances, the largest and smallest. The largest clearance, S suffix maximum, is equal to the difference between the largest limit hole size and the smallest limit shaft size. S maximum is equal D maximum of the hole, big D, minus small d minimum, it's minimum diameter of the shaft. The smallest clearance, S minimum, is equal to the difference between the smallest limit hole size and the largest limit shaft size. S suffix minimum is equal minimum diameter of the hole minus maximum diameter of the shaft. Formulas can be converted to calculate S suffix maximum and S suffix minimum, or largest clearance and smallest clearance through deviations. We use these two formulas. S suffix maximum is equal upper limit deviation of the hole minus lower limit deviation of the shaft, its largest clearance, and smallest clearance is equal lower limit deviation of the hole minus upper limit deviation of the shaft. Next type of fits, it's interference fits. Interference fits. To form an interference fit, the diameter of the shaft before assembly must necessarily be greater than diameter of the hole. In the assembled state, the diameters of both parts in the joint area are equalized. Interference fits are characterized by limit interferences. The largest interference, N suffix maximum, is equal to the difference between the largest shaft size limit and the smallest hole size limit. And we have the formula to calculate the largest interference. And maximum is equal small d maximum, it's maximum diameter of the shaft minus minimum diameter of the hole minus big D minimum. And it's equal upper limit deviation of the shaft minus lower limit deviation of the hole. The smallest interference N minimum is equal to the difference between the smallest shaft size limit and the largest hole size limit. N minimum is equal lower diameter, minimum diameter of the shaft minus maximum diameter of the hole, and it's equal lower limit deviation of the shaft minus upper limit deviation of the hole. Third type of fits is transition fits. In transitional fits, both clearances and interferences can form in the joints of parts. Transition fits are characterized by largest clearances and largest interferences. Largest clearances is equal maximum diameter of the hole minus minimum diameter of the shaft, or it's equal upper limit deviation of the hole minus lower limit deviation of the shaft. And largest interference. Largest interference in connection is equal maximum diameter of the shaft minus minimum diameter of the hole. And it's equal upper limit deviation of the shaft minus lower limit deviation of the hole. The fit tolerance is equal to the sum of the tolerances of the hole and the shaft that make up the connection. So the fit tolerance is equal tolerance field of the hole plus tolerance field of the shaft. From the layout of the fit tolerance fields comes out tolerance field of the clearance fit is equal maximum clearance minus minimum clearance. Tolerance field of the interference fit is equal maximum interference minus minimum interference in the fit. And tolerance field in transition fit is equal maximum clearance plus maximum interference. Thank you for your attention. Goodbye. See you next time.